Today I'm going to be going through a FRQ problem for AP CALC BC. Now this was taken from the 2019 exam on the College Board website. Okay, so we have three subparts to this question. There's definite integrals. Okay, let's get started with the first part, which is A. Let's go through the question together. So the question says, consider the family of functions f of x, which is equal to 1 over x squared minus 2x plus k, where k is a constant. Okay. Find the value of k for k is greater than 0, such that the slope of the line tangent to the graph of f at x equals 0 equals 6. Okay, so the slope of the line tangent to a graph at any point is essentially its derivative, because the derivative is essentially the slope of a function. So we have that the slope of the line, which is the first derivative for this function, f prime of x at x equals 0 equals 6. Okay, so we have f prime of 0. We have f prime of 0 equals 6. Okay. Since we have f of x, we'll just we'll try and figure out f prime of x first. So that's d over dx of 1 over x squared minus 2x plus k. Okay, let's just rewrite this to make it easier for ourselves. So that would be x squared minus 2x plus k raised to the negative first power. Okay, so we're going to use power rule first to bring the minus 1 out to the front, and then the original function, and then again power rule, so you subtract 1 from the exponent, and then we're going to use chain rule because we have to also factor in the integral of the function if it's not 1. So in this case, the derivative of the inside function is 2x minus 2. So the integral of x squared here is 2 using power rule. And then the same thing with 2x. The integral is just 2. And obviously, since k is a constant, the derivative is 0. So we're not going to mention that. Okay. So that's minus 1 into x squared minus 2x plus k raised to the negative second power into 2x minus 2. So we're going to rewrite that. That's going to be minus 1 into 2x minus 2 over x squared minus 2x plus k whole squared. Okay, and that is f prime of x. So what we have given to us is f prime of 0. So we're just going to plug in 0 for x in this function above. So that's minus 1 into 2 times 0 minus 2 over 0 minus 2 times 0 plus k whole squared. So that is negative 1 into 0 minus 2. So that's negative 2 over 0 minus 0 plus k whole squared. Okay, which is 2 over k squared. And we have that f prime of 0 is equal to 6, which means 2 over k squared. 2 over k squared is equals 6. Okay, we're just going to multiply both sides by k squared. So the k squared cancels out on the left-hand side, and we have 2 is equal to 6 k squared. Now we're going to divide both sides by 6. So we have divide by 6, divide by 6. The 6's cancel out on this side, and so we have an 2 and 6 cancel out, so that's 1 over 3. So k squared is equal to 1 over 3, which means k is equal to the square root of 1 over 3. Okay, I think that's all the question asked us for. Yes, just the value of k. So that is k is equal to 1 over root 3. Okay, subpart B. Looks like a definite integral. Okay, for k is equal to -8, find the value of f of x evaluated from 0 to 1. Okay, the integral of f of x evaluated from 0 to 1. Okay, so let's just set this equal to I. So f of x, where k is equal to -8, is x squared minus 2x plus k. Okay, x squared minus 2x. Since it's -8, this is going to be -8. Okay, so we're going to go about integrating this using partial fractions. So what we're going to do is we're going to factor this into 2 or 3 factors. Since this is a quadratic equation, there's going to be 2 factors. And then what we're going to do is split it into 2 equal parts. I'll show you what I mean in just a second. Not equal parts, just 2 parts that add up to give this term, just to make it easier for ourselves to integrate this. So this is going to be split into x squared minus 4x plus 2x minus 8. Now we're going to factor this out by splitting the middle term. So that will be x into x minus 4 plus 2 into x minus 4, which is equal to the integral 0 to 1 from 1 over x plus 2 into x minus 4. Okay, now we're just going to look at this function here. We're going to forget about the integral for a second. We're going to take this function here, that's 1 over x plus 2, x minus 4, and we're going to equate it to a over x plus 2 plus b over x minus 4, and we're going to try and figure out the values of a and b. So we're just going to multiply both sides by x plus 2 into x minus 4. So that will be x plus 2 over x minus 4 into x plus 2 over x minus 4, which is equal to a into x plus 2, x plus 2, x minus 4, plus b into x plus 2, x minus 4 over x minus 4. So obviously on the right hand side, they cancel out. And on the left hand side, you can see the x plus 2 terms cancel out in the first one. And for the second one, x minus 4 cancels out. So we're left with 1 is equal to a into x minus 4 plus b into x plus 2. Now how we're going to go about figuring out the values of a and b is we're going to set x equal to certain values so that one of the terms, which is either a into x minus 4 or b into x plus 2, cancels out. So for the first one, we're going to try and cancel out this first term right here, which is a into x minus 4. So let's set x equal to 4, which would make this whole thing 0. So for x equals 4, 1 would be equal to a into 4 minus 4, which is 0, plus b into 4 plus 2. So 1 is equal to 0 plus 6b. So 1 is equal to 6b. We're going to divide both sides by 6. So the 6's on the right hand side cancel out, and we're left with b is equal to 1 over 6. Now we're going to do the same thing for the second term. For x equals, we're going to have to set x to -2 to make this term 0. So we're going to set x to -2, and that would be 1 is equal to a into -2 minus 4 plus b into -2 plus 2, which is 0. So that would be 1 equals minus 6a plus 0. So 1 is equal to -6a, which we're going to divide both sides by -6. So -6 is on the right hand side cancel out, and we're left with a is equal to negative 1 over 6. So we have the values of a and b. Now we're just going to simply rewrite this original integral using a and b. So that would be I is equal to a over a is negative 1 over 6, x plus 2 plus 1 over 6, b is x plus 4. Right, now we're going to use a couple properties of integrals. The first one, we're just going to divide this into two separate integrals. So that's 0 to 1 minus 1 over 6 x plus 2 plus, this is the second integral, okay, and then we're going to bring the coefficient out because this is a definite integral, and so we're going to have to evaluate it, and we don't want to have to deal with the negative 1 over 6 because it's going to cancel out anyways. Or sorry, it's going to be factored out anyways. Plus 1 over 6, 0 to 1, 1 over, oh wait, I'm sorry. Is it, sorry, it's x minus 4. I'm sorry about that. So that's 1 over x minus 4 dx. And that would be negative 1 over 6. And the integral of any function of the type 1 over x whatever is the natural log of x in a mod sign plus 2. And since this is a definite integral, we still have to evaluate it from 0 to 1. Same thing here. Natural log of x minus 4 evaluated from 0 to 1. Okay. So that's negative 1 over 6 into the natural log of 1 plus 2 minus the natural log of 0 plus 2 plus 1 over 6 into the natural log of 1 minus 4 minus the natural log of 0 minus 4. Okay. Yep. So that's negative 1 over 6, natural log of 3 minus natural log of 2 plus 1 over 6, natural log of negative 3, but since it's in a mod sign, it'll become positive eventually. So in the next step, we'll convert these mods to be positive. So that's natural log of 3 minus natural log of 2 plus 1 over 6 into natural log of 3 minus natural log of 4. Now let's multiply the coefficients. So that's minus 1 over 6 log 3 plus 1 over 6 log 2. Just rewrite that. Plus 1 over 6 log 3 minus 1 over 6 log 4. So clearly these two terms are going to cancel out since they're positive and negative have the same value. Okay, and there's a property of, so on the AP exam, you could probably just leave this answer as is. You don't have to simplify. And it's always a good idea to leave it this way so that you don't make any mistakes when simplifying, because that could obviously lose you points. But we're gonna simplify this anyways just for the video. So this would be 1 over 6 natural log of 2 minus 1 over 6 natural log of 4. Now there's a property of logs that will allow us to manipulate this further. So the property is, you can, obviously we're going to rewrite this first as an exponent of 2. And there's a property of logs where you can bring this exponent out to the front. So that's minus 1 to ln 2. So that's 1 over 6 natural log of 2 minus 2 over 6 natural log of 2, which is minus 1 over 6 natural log of 2. that's the answer to this problem. Again, on the AP exam, you can probably leave your final answer this way, and it's not a problem because, and it's always, again, recommended to leave it this way so that you don't lose any points trying to simplify. Okay, so third question here. Let's just put the answer here. Okay, for k is equal to 1, find the value of f of x evaluated, the integral of f of x evaluated from 0 to 2, or show that it diverges. Okay, so we have a possibility that it might diverge. Let's see. So the question, I'm going to rewrite it. So we have the integral of f of x from 0 to 2, f of x dx, and we want to either find the value or show that it diverges. Okay, so f of x is 0 to 1 over x squared. F of x is x squared minus 2x plus, and k is 1 in this case, okay. Squared minus 2x plus 1. So I guess we could use partial fractions here, but it's easier to evaluate this using the completing the square method. Okay, so let's try and complete the square here. So it's 0 to 2. Oh, wait. Okay, so this is just x minus 1 whole squared. If you look at it closely, the 2ab term, minus 2x, is just minus 2 times 1 times 1. And the coefficient of x is 1. The third term is 1, so we don't have to complete the square. This is already of the form x minus 1 whole squared. Okay, that makes it a whole lot easier. Okay, so by looking at this integral, we can see that since there's this x minus 1 term, at x is equal to 1, this would be 1 over 0 squared, which is infinity, which means that there's a singularity in this integral. So what we have to do in situations like these, especially when we're evaluating over an interval, is we have to work around this singularity and essentially split the integral into 2 or 3 parts around the singularity. So we're going to do just that here. We're going to use a property of definite integrals, which will allow us to split this integral into 2. I'm going to write the property out here first. And that property is for a to b of an integral, you can always split it from a... Sorry. Let me just do it this way. A to b f of x dx plus b to c f of x dx, where so we're just going to split this again into 2 parts, from 0 to 1 and from 1 to 2, because there's a singularity at x is equal to 1. So we're going to rewrite this as 0 to 1, 1 over x minus 1 whole squared dx, plus 1 over x minus 1 whole squared dx evaluated from 1 to 2. Okay. Yeah, and then we're going to, since this is an improper integral, we're going to use a limit. So the limit's going to be b as b approaches. So since we have 1 twice here, and we're going to have to use limits for both these terms, the first one is going to be limit as b approaches b. 1 minus essentially means that it's just below 1, so not quite 1. So that's going to be 0 to b 1 over x minus 1 whole squared dx, plus we're going to use a limit here, but it's going to be to 1 plus, which means a little over 1. So that's b to 2, 1 over x minus 1 whole squared dx. Okay, so this is going to be limit b 1 minus, and the integral of this is just, well, let's rewrite this first actually. 0 to b, and this is going to be x minus 1 raised to negative 2 dx plus limit b 1 plus from b to 2 x minus 1 raised to the negative second power dx. So this is limit b raised to 1 minus, and the integral of this is just x minus 1 minus 2 plus 1 over minus 2 plus 1, evaluated of course from 0 to b. This is limit b1 plus, and it's the same thing, x minus 1 over minus 2 plus 1, raised to minus 2 plus 1 over minus 2 plus 1 from b to 2. Okay, so upon simplifying, what do we get? This is x minus 1 over negative 1 over negative 1, 0 to b, same thing for the second term. It's x minus 1 over raised to negative 1 over negative 1. So this is limit b approaches 1 minus 1 over x minus 1, 0 to b, plus limit as b approaches 1 plus for minus 1 over x minus 1 from b to 2. Okay, which is equal to limit as b approaches 1 minus for okay, we're going to value this integral. So that's minus 1 over b minus 1. Minus 1 over 0 minus 1. Plus limit as b approaches 1 plus 4 minus 1 over 2 minus 1 minus 1 over b minus 1. Okay, so from this, we can clearly see that both of these, if b was equal to 1, would evaluate to negative 1 over 0, which is infinity. So these integrals do not converge, which means that this is a diverging integral. And obviously on the AP exam, you have to state why you think it's a diverging integral. So the reason here is because limit as b approaches negative infinity, 1 minus for minus 1 over b minus 1, and limit as b approaches 1 plus for negative 1 over b minus 1 is infinity, and therefore the integral is diverging.